Okay, this is Minder Chen. This is a video lecture on systems development lifecycle. In short, we call it SDLC. For people who work in the software industry, when you say SDLC, they know what you mean by that. It's about managing the systems development process. We take the so-called life cycle approach, divide the system development effort into different stages, and each of the stage we will deliver different documents, deliverable, and those stages are kind of connected to each other. So let's look at what's involved. There are different versions of the system development so-called life cycle stages. In this simplified version, I have 4 stages. So you do need to remember these 4 stages. Okay, and it's sequencing: planning, analysis, design, and implementation. Okay, and we'll elaborate a little bit on those 4 stages, what's involved. But planning, basically, you need to find out how big is your project, what resource do you have, and what kind of commitment and deadline that you may be dealing with. And that's the first stage. And once you decided you're going to do it, then you move to the next stage, which is analysis stage. Analysis and the design are the core of the system development effort. Here I'm actually making a little bit comparison between the two. In the analysis phase, you're focusing on what, which is what do I need, what problem I want to solve, or what opportunity we try to we try to achieve. And in terms of software development, we often use the term called requirement. We try to understand what's the requirement. Okay, what do we have to do here? What the system supposed to help us with? And this is where the user, end user, or domain expert will be very, very useful. You want to get them involved so they will specify the requirement for you. You could be a so-called professional system analyst, helping the user to identify their requirement in a very specific way. And however, the user's involvement is critical to any system development project. And this is where the soft and people skill can be very, very helpful. So I can see all the student major in business potentially can be trained to be a good system analyst. You don't really need to know a lot about information system technology per se, as long as you have a good understanding of what information system is about. And through some training, you can be an actually experienced system analyst. The design phase is about building the solution. It's to answer the question of how. How should we do this? Okay. And the document that will be generated during the design phase is what we usually refer as a specification, design specification. It could be the specification for your database design, for your business logic, for even your user interface. Okay. And rely more or less on your technical skill. You do need to know technology, particularly in the so-called physical design phase. Sometimes we try to actually do the design in the abstract, we call it logical design. You can come up with a design without referring to specific technology. You can say, oh, well, we're going to store this in the database. You don't have to say which database. You don't even have to say that's relational database. And that's kind of logical level. But eventually you say, okay, I'm going to use SQL Server. I need to have those table, those column, and in such detail, then you're talking about the physical design, not a logical design anymore. And eventually it's implementation. Implementation is very, it's broadly defined here. It means programming, coding, testing, training the users, and convert the old system into the new system, prepare the organization to the potential change, to the business procedure and processes, and all of that. Okay, it's something you need to take it seriously. And some of the implementation effort, preparing organization to be ready for the final conversion to the new system, actually has to start quite early. Okay, and there are three aspects in the triangle here regarding what we need to look at in a typical information system. One is the data aspect. Just like when we study database, we need to identify what, in the conceptual level, what entities are involved, which we need to remember those entity or objects, and how those entities are related to each other. We usually call it entity relationship model. And eventually that will turn into your database design, which will be table and relationship among tables. That's the data aspect. The process aspect is about how we're going to take care of some business transactions in order to maintain the data we want to store in the database. It's business process, business logic, and UI stands for user interface, which is how we're going to design the user interface such that the user can enter the data into our system or retrieve the data they wanted from our system. Okay. And a lot of time we do use some approach called prototyping. I think I mentioned prototyping in the context of a group project. Prototyping means that you will build something very quickly, which can be up and running. It's not perfect. Sometimes doesn't have a lot of detailed business logic behind it. And a lot of time prototyping will be focusing on the user interface part of it. How does the system may looks like? Behind the scene, the logic, the processing logic may not be implemented yet. Okay. And just clarifying some of the term we use when you refer to the methodology. Some people, if you're involved in a software development project, one question you may want to ask first is like, what methodology are we using? Okay. And people will say, oh, we're using the traditional waterfall model. I'll explain that a little bit later. And we're using UML methodology, unifying process. They wouldn't usually know what kind of methodology they use. This is a generic model, okay, we're presenting here. So the two part of the methodology, not a lot of people actually understand this clearly. One is the process, like what stages you're going to go through. That's the life cycle concept. The second part is the modeling technique, which means when you design database, are you using normalization? Are you using ER modeling, entity relationship modeling? When you try to lay out your business process, are you going to use like business process modeling notation approach, or you can using the activity diagram in UML? Okay, I'm using certain terms which may be new to you, but it's just as an example of people. There are specific way to capture those design about the data or the design of your business process. Okay, and usually you need to specify the modeling technique that you're going to use. Got it? Okay. And the reason this life cycle approach is important is that at the end of each stage, we expect the project development team to generate some kind of deliverable. And usually there are documentations, diagram, meeting notes, a list of requirements, and that would help us as a manager managing the project to have some kind of visibility, what has been done. Okay, without the documentation, if you ever seen a system analyst work with people in terms of defining requirement, they just go into organization and start chatting to people. Oh, what do you think about this? What's coming? And let me see what you have. And it's almost like sometimes like casual chatting. But believe it or not, experienced analysts usually they know exactly what they're looking for, and their inquiry, their questioning, it's not random. It's actually have specific purpose. They know what kind of things happening in the organization may have a major impact to the requirement or to the design of the system. That's why sometimes they will chase you down and say, explain that again clearly to me, because that has a significant meaning. And this is where a really experienced system analyst will be different than a junior one, which may not have that sense of the potential impact of some statement by the user to the end to the system. Okay. This is just another version. We call it a structured project system development life cycle. We still have that planning stage, and usually we do some kind of cost-benefit analysis, defining a project scope. Okay, the scope sometimes may change throughout the life cycle, but you need to manage that clearly. Make sure you don't change it easily. The analysis phase, the deliverable, the documentation which will be generated at the end of analysis phase is the so-called requirements, systems requirement, software requirement, and eventually the design. Okay. Here's the deliverable at the end of the design phase is design specification. Okay. Let me just give you a quick example other than software. Okay. Imagine you are launching a major marketing campaign. Then what will be the analysis phase deliverable? Okay, and you need to actually go to your stakeholder, which could be a product managers or the marketing director, and find out what they expect out of this initiative. Okay, at the end, it could be a list of things. This marketing campaign will generate the following result, will achieve the following objective. That's kind of your requirement. And the design spec is you're going to design it, you're going to host an event, and then you're going to lay it out in the event. Who are you going to invite and what will be the activity in the event? That's a little bit of your design spec and in terms of how you can achieve those requirements which you can lay out in front of you earlier. Got it? Okay. So once again, I try to emphasize this is pretty generic. Okay, you're not dealing with software development. Any major initiative which takes a long time, take a lot of people involved to get it done. Thinking about this kind of life cycle approach. Eventually, it's implementation. Okay, carry that out, make sure it happened smoothly, and at the end of implementation, it's the implemented system. Okay. And here I separated the testing, integration, and installation out of implementation. Sometimes this is part of implementation. Okay, here I just want to make it clear. Once someone has written the code, you still need to go through the testing, integrate a lot of modules together, see whether they will work with each other, and eventually install it in the platform such that it will be eventually become operational. Okay, bring the system online to be up and running. Okay, and then that will be the operation and maintenance phase. Okay. You will still probably spend some effort and money in maintaining the system. Typical software maintenance project probably will cost you about 15% of the initial budget in building it. Okay, and up to a point, the old system may not be adequate for the changing business environment, and that's where we may come back and actually redevelop a system to replace it. Okay, can be a totally new system or just making some major adjustment to the existing systems. Okay, here I mark a number of things which is critical to the success of system development project. One is users' participation. Okay, you want to get the user involved. They do feel there's a kind of ownership. Okay, we contribute to it, we're part of the project team. It's much easier for you to work with them, and also they would come out and defend you to your final project because they feel that they are part of the team. If your users start to refer to the system as like your system, you're in trouble. Okay, if the users say our system, you're in pretty good shape. Okay, and that's the difference. Okay, make sure they do feel that they are part of the owners and development team in some way. Documentation is very important. Software developer, analyst or designer, most of their job is it's more knowledge worker. As a knowledge worker, most of what they have done is less visible. Okay, just I said earlier, if I'm designing the database, I may be drawing some diagram, whatever. If you come and say, what have you done? And the only thing I can show you is that data model that I have created. Okay, so you do need to manage those documentation, because without that, there's no way you can keep track of what has been done, how much effort has been put in so far. I mentioned modeling technique earlier. They are tools to help us to document like a database design, a process design, or user interface. And the two types of software, one is called computer-aided software engineering tool. We call it CASE tool. I used to do a lot of research in the CASE tool arena, and in particular integrated CASE tool. And the second category is called IDE. It's integrated development environment. For instance, if you use Microsoft development tool, it's called Visual Studio. It's an example of IDE. Some of the more up-to-date IDE, integrated development environment, has a little bit of functionality of those which traditionally is categorized as CASE tool in terms of modeling. Okay, this tends to be more on the programming side. This CASE tool tends to focus on supporting analysis and design phase. Okay, and IDE tends to focus on supporting the implementation part of it, of the system development effort. Okay, do try to use the right tool. Software development is not easy. You want to actually use the best tool you can find, which is appropriate to your project. Eventually, there's some quality assurance tool, particularly for the testing. There's specifically so-called testing tool, which can help you to test the software. Software testing is very, very challenging. Without the tool, it's very difficult to ensure that you have a thorough tested system. Okay. This diagram tries to explain the term called waterfall model, which is the earliest system development cycle model called waterfall. So far, we mentioned like two different kind of life cycle models, slightly different. Those two are more or less like a waterfall model implicitly. The waterfall model showing here imply you have to finish the planning before you can move on to the analysis phase. You have to finish analysis phase before you can move on to the design phase. So it's step by step, like a waterfall. Okay, and eventually there's not much of the feedback loop. Okay, there's no feedback. And that's just not realistic. And also this approach tends to last longer. And nowadays, not a lot of organization has the patience to wait for a long time until they see the final system come out of this stages that you're working on. So we pretty much kind of abandon the waterfall model. However, it's still very useful to understand kind of different stages and what's involved, because even later we're going to introduce some variation of this waterfall model. You still need to do some kind of analysis somewhere, sometime, and you still need to do some kind of design. So it's worthwhile to paying attention to the basic waterfall model as the background information for you to understand other approach. In the planning phase, once again, you try to identify and prioritize various development projects, or in order to identify your scope. Analysis phase, there's one thing which I often refer to as as-is model and to-be model. For your requirement, particularly, you try to understand the existing system. That's as-is model. You try to describe what the system looks like now. That's as-is. To-be model means the future system, the new system. That's the to-be system. So in this case, that's where actually you want to deal. In analyzing a system, a lot of times we do start it with as-is model, understand the current system, but eventually we want to move to the so-called to-be model. So one suggestion is don't spend too much time in understanding existing system, because that's going to change. You only want to understand enough that you know how to change it or what are the issue or problem you try to solve. Got it? Okay. So, and eventually you want to move to the to-be system. You can always come back and say, oh, what was the current situation now? This is what we want to design, but I think I'm missing something. Tell me what's currently being done. Is this new design or new requirements what you really wanted? Okay, so that's, you can always go back and study the existing system. Otherwise, you may be falling into some a problem that we call it analysis paralysis. Okay, you'll be paralyzed by keep analyzing the current system to the depth, because there's so many details about the existing system that it will consume all your time, and eventually you won't be able to get out of it. Okay, but believe it or not, a lot of those detail, a lot of those current system, it's going to change. So it's not worthwhile to understand it thoroughly, to spend that much time and resources. Okay, so it's very important to understand this. Design, once again, there's a logical part and physical part of the design, and design spec is the deliverable out of the design process. Once again, the implementation may involve programming, testing, training, end user training, etc., and the installation of the system to the new platform. And eventually it's the operation. Okay. On the operation side, still involve some kind of maintenance, which is bug fix or upgrades of the existing system. Another approach which helps us to manage the system once it's in operation, it's called IT service management. Okay, and there's a standard called ITIL, I-T-I-L. Okay, it actually stands for IT infrastructure library. We don't talk about it that way anymore. We just say ITIL. It's really IT service management methodology. It's actually a standard. Let me just give you an example. If you have any problem with your computer, you need our IT department to help you. There's an IT help desk. You can send in an email or call them. Once you have done that, and they will actually send an email to you and say, we already created a work order on your request, and we're working on it. And then once they finish, they will actually give you an update and say this problem has been solved. That's part of the so-called IT service management approach. Keep track of all the inquiry, problem ticket. We usually call it problem ticket. They will generate a ticket to keep track of your problem. Okay, not a traffic ticket that you get. Okay, speeding ticket. It's the ticket. Okay, that's kind of document that we receive your the problem that you asked us to solve. Okay, we're working on it, and then we'll keep track of it. Got it? Okay, so that's the waterfall model. Okay, this slide I'm going to just let you read it. This kind of explain different phases again, which we pretty much cover. I just want to leave this here kind of for your reference. You can kind of study a little bit better. So what's the variation or revision to the waterfall model? Okay, and first approach is to we call it spiral model. Okay, the spiral model certainly go this way. Okay, kind of go this way, go spiral. To some extent, we're still going through different phases. Those pretty much live up planning, analysis, design, implementation phase, but we're going through it very fast and several times. Got it? It's almost like I'm going through my life cycle very quickly with one version, and then I'm going to extend it, expand it, enhance it, and go through it another time. So this is like first run of going through the life cycle. Okay, very quickly analyze system, building prototype. Okay, if you look at it. Okay, eventually the prototype become the operational system, but first the prototype can be very primitive, and then we'll use it to prove the concept of operation. I think if you work with anybody in the federal government, sometimes they call it CONOP, which is concept operation. It's proof of concept. Okay, quickly have something up and running and say, hey, this sounds like what you wanted. Okay, if you really like it, let's go ahead and continue, do a more detailed analysis. Okay, in the spiral model, another thing they emphasize quite a bit is the risk analysis. Before you commit to the second run of the prototype, you want to certainly understand the requirements, but also you need to identify the potential risk. Okay, are we heading in the right direction? If this is going to be too risky, maybe you want to cancel the project. Okay, and eventually you continue, you identify the software requirement, and you go and come back, do maybe the third prototype, and the system will has more functionality, eventually evolve into the final system that you want to develop. Okay, the detail here is not important, but the concept going through the life cycle very quickly. Okay, it's almost like a versioning concept. Let's build a version 0.1. Okay, identify those critical functions. Okay, when I say version 0.1, 0.5, for most of the system, the 80% of the functionality probably only costs you maybe 20% of the effort to develop. Okay, and then there are other things which are less important. Then you can pay attention to it later on. Okay. So this spiral model, to some extent, it's equivalent to the so-called prototyping concept. Okay, building the prototype. Prototype is very important. A lot of time, the end user cannot articulate their requirement to you as a system analyst because they never actually seen a system out there to support their business. But once they have seen your prototype, they can articulate it better. Oh, I didn't know that you can do this, and can you do that for me? And they're giving you additional requirement. Okay, so it's an iterative process. You don't expect to get all the requirement out at one shot. Okay, in my opinion, when you work with the user, try to identify requirement. It's actually not only it's an iterative process, but also it's a process you're educating with each other. Okay, you need to educate them about how the system can help them. They will educate you about what they really want from the business perspective. Okay, so the prototyping can help quite a bit. The challenge of identifying requirement, we call it requirement elicitation. This is part of the analysis phase. Okay, requirement analysis. Got it? Okay. In the analysis phase, the deliverable, major deliverable is in the analysis phase, the major deliverable is the requirement. Okay. In this Dilbert's comic strip, it states that your user requirement include 400 features, like a long shopping list. Okay, and here the statement said, do you realize that no human would be able to use a product with that level of complexity? Okay, and this this guy agreed and say, yeah, that's a good point. I'll add another requirement to the list, which is say easy to use. Okay. What this tells us is you need to have you need to have a set of prioritized requirements. And usually in requirement documentation, we would pretty much identify requirement as like must have and nice to have. Okay. Must have is that without this system is not acceptable. Nice to have is that, well, we like it, but we can live without it. If you have time, you have resources, let's do it. But it's not essential. Okay, we'll come back to talk about, we call it essential requirement. Okay, what's the most important one? That's the so-called 80% rule. Okay, 80-20% rule. What are the 80% of the most important function, which probably reflected in 20% of your requirement on your list? Okay, so when you try to build a system focusing on those essential requirement. One way, just like in the previous slide, is showing that when you talk, one way to gather requirement, elicit requirements through interviewing user. That's the most common approach. There are other ways, like I will go into organization, I will start collecting their document. What are the document or form? If I need to build something for, say, our university's advising center, I would just go to the advising center and say, just show me all the form that you use. Okay, and then I would observe. Okay, I would just sit there and see how those advisors are doing their advising job. What kind of question people may have, what kind of phone they may be receiving or email they may be receiving. So you can actually just observe. Okay, interview and observation are different. Okay, interview, basically you go and then start talking to them. Okay, you can use different requirement gathering technique like observations, collecting documentation, but interviewing the user in that application domain is the most useful and most commonly used one. Okay, the diagram is pretty detailed. I don't want to bother you with all those details, but you started from here. Okay, you start plan your interview. Okay, in terms of what you try to get out of it, try to understand the background information about the unit you want to, or the user you want to interview. Prepare a list of the things that you need to get ready, and also probably a list of potential questions you may want to ask. Understand the background of the people you're going to deal with, and schedule. Sometimes the interview may occur over a whole week, so you need to actually have a list of kind of logistic items that you need to pay attention to, and some contingency planning. Okay, in case some equipment doesn't work, what do you do? Okay, in actual interviewing, okay, prepare a list of questions, can be open-ended or closed. Open-ended, just like I think I asked all the questions I want to know, but is there anything that you think are important to this new system that I may not have paying attention to? Okay, that's kind of open-ended. Tell me anything that we haven't covered so far that you think I need to know. Okay, that's kind of an open-ended question. And make sure you work well with the end user. And sometimes you don't want to sidetrack to something else, which is they may be just complaining about something irrelevant to your project. In that case, you need to bring them back. Otherwise, you're wasting the time. Eventually, you need to document the result of your interview to create the deliverable, to create the documentation, using some modeling technique to kind of document what you have captures. Okay, because that's the proof. Okay, you can show your manager and say, hey, I went to an interview and this is what I got out of the user. Okay, that's the documentation. believe it or not, different stakeholder, okay, not shareholder, okay, stakeholder. What does stakeholder mean? Go ahead.
People that are like affected by the company's like results.
Yes, anybody who may be affected by, in the context of software development, so anybody who may be affected by the new system was considered a stakeholder. Certainly the end user, the people who will use it will be the stakeholder. And sometimes the manager who may receive the report from the system may be the stakeholder. And if the system is used by a salesperson, then maybe the customer will be indirectly affected by the new system, and they should be considered as a stakeholder. So anybody who may be impacted positively or negatively will be considered stakeholders. Okay, those are the people you want to get their viewpoint. What's their perspective? Okay. If don't read the kind of the tech lines here. Okay, which one? Okay, I trust you not looking at the words here. Which one is really what the user wants? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's hard to tell, but this end up to be what the user really wants. Okay, which one? Okay, I trust you're not looking the answer. Which one is how the customer was billed, was charged? If you hire a really bad consulting firm, try to squeeze a lot of money from you. Which one do you think? Number A, this very expensive roller coaster ride. Okay. Let's see. Okay. Which one? Okay. How the project was documented. Documentation. It's here. What does that mean? No documentation. They give you and say, this is what it is. It's functional. Buy, pay me, and say goodbye. They don't give you any documentation. Why they don't give you a lot of documentation? So you have to hire them back to fix the problem. Okay, because they know how to fix it. Give you documentation can help you in terms of maintaining the system. So you have the right to ask for proper documentation, not just a piece of software. Although you hire people to build the software, but actually you actually are entitled to get their documentation. Actually, you need to review their documentation along the way. Don't wait until the end and say, oh, give me all your documentation. When they say, I'm done with the analysis, they present their finding. Ask them for all those documentation. When they design it, review the design before they do lots of coding and ask for the design document. Okay, that's how you can get it. Otherwise, it will be delivered just like this, which means nothing. Okay, and okay, and this is one. Number one is how the customer explain it. This is what they want. This is how they explain it. Why?
You're not sure what they want?
They're not sure what they want. Sometimes, yes, they're not sure what they want, or they do not know how to articulate what they really want clearly to you, because they never have built this swing or seen one before, so they just have some rough idea. They never have experience of a modern day information system, and that's how. So it's hard for them to describe to you what they want out of the new system. They may be based on their old-fashioned experience, the old experience of the file cabinet-based system, to describe what they want to you, which may not be the best way. Okay, got it? Okay, So I'll let you study this. Okay. Maybe I can come up with a exam question here. Okay. I like pictures. Okay. Okay. Ready? As I mentioned just like earlier, when you move along the system development life cycle, you do want to review what has been done. Okay, don't wait until the testing or implementation phase to check and double check the design or even the requirement. Okay, there's something called validation and verification. In particular, verification, you want to verify all the requirement identified by the system analyst. You want to verify the design spec as an end user. Okay, make sure it's done properly, and then to move on to the next stage. So pretty much they need to get your signature before they can move on. The reason is that if there's anything wrong, they missed some major requirement, there's a major design flaw. If you do not catch it earlier and it will show up in your operational phase, then it will be very costly. Okay? And that's why you do want to have this verification, validation function building into your life cycle at each of the stage. You want to actually work on it, okay? And to reduce the risk down the road and the cost down the road, okay?